Today we'll discuss how to determine the deflection of a frame by unit load method. You know what is unit load method? In unit load method, you have to find out the deflection. Delta is equal to 0 to L integration capital M small m by EI into dx, where capital M is the bending moment at the section due to external forces, and small m the bending moment at the section due to unit loading, and E is the modulus of elasticity, and I is the moment of inertia of the section. And this method is applicable to rigid frame where only the flexural effect is considered. In this analysis, the effect of axial force and shear forces are neglected, and you can find out what is the deflection at any point using this relation. Delta is equal to integration 0 to L capital M small m by EI into dx. So coming to one example, compute the horizontal and vertical displacement of the free end D of the frame by unit load method as shown in figure. EI is given 2 into 10 to the power 4 kilonewton meter square. So this is one frame ABCD. AB and CD is the vertical member and BC is the horizontal member. And here on the horizontal member BC, there is present one load, concentrated load 80 kilonewton at a distance 2 meters from the point B and 4 meters from the point C. Then the moment of inertia is given for AB 3I, BC 2I and CD I. And the length of the frame is given AB vertical member 5 meters and BC horizontal member 6 meters and CD vertical member 4 meters. And you have to find out what is the horizontal and vertical displacement at the free end D. So here what you have to do? So for vertical deflection, you have to apply vertical unit load, and for the horizontal deflection, you have to apply the horizontal unit load. So first you have to consider the external load. You have to find out the moment of each member of a frame. Then by considering the unit vertical force, you have to find out the moment at each member of a frame. Then you have to apply unit horizontal force. You have to find out the moment at each member of a frame. So you have to find out the deflection by unit load method. So what is the formula? The vertical deflection at D is equal to delta VD is equal to integration 0 to L capital M small m1 by EI into dx. Similarly, the horizontal deflection you can find out using this formula. The horizontal deflection at D is equal to delta HT is equal to integration 0 to L capital M small m2 by EI into dx, where capital M is the bending moment at the section due to external forces, and small m1 bending moment at the section due to unit vertical loading, and small m2 bending moment at the section due to unit horizontal loading. E is the modulus of elasticity and I is the moment of inertia of the section. You know, this is the you have to take care the capital M is the bending moment due to the external loading. Small m1 is the bending moment at the section due to unit vertical loading, and small m2 is the bending moment at the section due to unit horizontal loading. So after getting this small m1 and small m2, then you can find out using this relation what is the vertical deflection at D and what is horizontal deflection at D. So first to find out what is the bending moment due to external load. First to find out the bending moment of each member of the entire structure due to external load. So first to start from this one for CD member, then you take BC member, but in BC member you have to take two sections. Between E and C you have to take one section, and between B and E you have to take another section, because this is the load. So the right of this load you have to take one section, and the left of load you have to take another section. and in AB member also you have to take one section. So here you have to take 4 sections. So one section is your between C and D, and the second section is between E and C, third section is between B and E, and fourth section is between A and B. So you have to find out what is the moment in this 4 section. So first to take a section at a distance from the 3 and D, and what is the moment here? What is the moment here? Because there is no load here this side, so the moment at x-axis is equal to 0. So here that is the moment in the section between C and D is equal to 0. And what is the moment here? So take a section at a distance x from the point C. So what is the moment here? What is the moment here? Because this side there is no load. So here also the moment is 0. This side there is no load. So the moment at this section is equal to 0. So here the moment is 0, and here also the moment is 0. Then you take another section between B and D at a distance x from the point C. So what is the moment here? What is the moment here? Because when you are considering right side, so this is the load is present at the point E. So what is this distance? So this distance is equal to x minus 4. This distance is equal to x minus 4. So what is the moment at the section? So this is your 80 into x minus 4. Minus 80 into x minus 4, because the rotation is your takes place in clockwise direction. So here you take the moment is equal to minus 80 into x minus 4. So between B and D, so the moment is equal to minus 80 into x minus 4. Then take another section at a distance x from the point B. So what is the moment here? What is the moment? So here you see, when we are considering this right side, so this is the load is present, external load 80 kilonewton. So what is the moment of this force about this section? What is the moment of this force about this section? So 80 into the perpendicular distance. So what is the perpendicular distance? 80 into 2, and this is clockwise rotation. So you have to take the sign convention, minus 80 into 2, minus 160 kilonewton meter. So you got the 4 moments in 4 sections between C and D, between E and C, between B and E, and between A and B. So here between C and D the moment is 0, and between C and D the moment is 0, and between E and B the moment is minus 80 into x minus 4, and between A and B the moment is minus 80 into 2. So just to write these moments in a tabular form. This is the moment. These are the moment. For DC 0, for C 0, then for EB minus 80 into x minus 4, and for AB this is minus 160. And you know for CD the origin is you take D, and for C you take the origin is your C, and for EB take the origin C. When you are taking the section from the point C, this is the section for EB. So here you have to take the integration limit is your from 4 to 6. Here you have to take the integration limit from the 4 to 6. You see here, so for EB member, when you are taking the section here, so you can take the section from E, and also you can take from the C. When you are taking the section from the E point, so here you have to take the integration limit is your from 0 to 2. But here you are taking the section from the C point. So what is the integration limit for this portion? So when x is equal to 4 meter, when x is equal to 4 meter, and when x is equal to 6 meter. So you have to take the integration limit from 4 to 6. When you are taking the section x from the point C between B and E, so here you have to take the x integration limit is from 4 to 6. First for DC member, integration limit is your 0 to 4, because you are taking from the section from the distance from the point D at D, so x is equal to 0, and when x is at C, so x is equal to 4 meter, and the moment is your 0 here. And for EC member, take the origin is your C, and you have to take the integration limit is your from 0 to 4. So x here 0 and x here 4. So you have to take for EC member the integration limit is your 0 to 4. But for B member, so you are taking, this is the section that from the C point you are taking. So you take the origin is your C, but you have to take the integration limit of x from 4 to 6. So because here x is equal to 4 and here x is equal to 6. Then for AB member, so this is the origin, this is the origin. So you are taking, this is the distance x. So at B, x is equal to 0 and at A, x is equal to 5 meter. So for AB member, take the integration limit is from 0 to 5. So origin for DC D and for CEC and for EBC and for BA B. And limit of integration is 0 to 4 for DC member, for C member 0 to 4 and for EB member 4 to 6 and for BA member 0 to 5. Then already we got the bending moment due to the external loading 0, 0 and minus 80 into x minus 4 and minus 160. Then the next you have to find out what is the vertical deflection at the point D. You have to apply unit vertical force at the point D. That is, you have to apply the force 1 kilonewton, unit force 1 kilonewton at the point D, and due to this force, find out what is the moment in all the members. Find out the moment in all the members. That is between C and D, and between E and C, and between B and E, and between A and B. So find out what is the moment between C and D, between E and C, between B and E, and between A and B, due to the unit vertical load. So this moment is where you take M1, small m1. So what is the moment here between C and D? So at a distance x from the free and D. So what is the moment here? So because this is the loading, vertical unit vertical loading, and this loading is your passing through the this point. So here the moment due to this force is equal to 0. So here the moment is equal to 0. Similarly, take another section at a distance x from the point C. So this is the section. So what is the moment here? What is the moment here? So this is the load is present at point D. So at the free end, this is the unit load present. So due to this unit load, so what is the moment here? This is your 1 into this distance is your perpendicular distance is x. So what is the moment here? Minus 1 into x. So here the moment is minus 1 into x. Similarly, take another section between B and E at a distance x from the point C. So what is the moment here? What is also the moment? Because this is the unit force, and due to this unit force, what is the moment here? Because this is the force and this is the perpendicular distance. So here the moment is equal to minus 1 into x. So here also the moment is minus 1 into x. Then take another section between A and B at a distance x from the point B. So what is the moment here? Well, just to put these moments in a table. So M1 is equal to for DC moment 0, and for C moment you got minus x, and for EB you got the moment minus x, and for BA got the moment minus. This is 1 into and perpendicular distance. So due to this force, due to unit force here, and what is the perpendicular distance here? Due to this one is your perpendicular distance is your 6 meter. So when you take the moment of this force, so you have to take this is the force and the perpendicular distance. So what is the moment here? Minus 1 into 6. This is the perpendicular distance, minus 1 into 6. So here this is your minus 6. Then find out what is the bending moment due to unit horizontal applied load. You have to find out, because you have to find out the deflection, horizontal deflection at D. So you have to apply unit horizontal force at D, and due to this unit horizontal force, find out what is the moment between C and D, between E and C, between B and E, and between A and B. So first to take a section at a distance x and from D and find out what is the moment here. What is the moment due to this unit horizontal force? So this is the force 1 kilonewton, and this is the perpendicular distance. So what is the moment here? This is your anti-clockwise direction. The direction is your anti-clockwise. So here you take the Sign convention of the moment is your positive. So 1 into x. So moment between C and D at the section is equal to 1 into x positive. Similarly, take another section between E and C at a distance x from the point C. So what is the moment here? Because this is the force and this is the perpendicular distance. What is the perpendicular distance? 4 meter. Here the moment is equal to 1 into 4. This is also anti-clockwise positive. Plus 1 into 4. Then what is the moment between B and D? So this is the section at a distance x from the point C. So what is the moment here? So here also moment, this is the force and the perpendicular distance is your 4 meter. Plus 1 into 4. So here also the moment is your plus 1 into 4. Then take another section at a distance x from the point B. So what is the moment here? This is the force and this is the perpendicular distance you have to take. This is the perpendicular distance. So here the perpendicular distance is your, this is x and this total is your 4. So 4 minus x. So this the perpendicular distance for horizontal force is your 4 minus x and this direction is your anti-clockwise. So 1 into 4 minus x. So here the moment is your equal to 1 into 4 minus x. So this is, so for DC the moment is your x because this is the 1 into x, and for C the moment is your 1 into 4, and for EB also 4, and for BA the moment is 4 minus x, or 1 into 4 minus x because this is the 4 meter and this is x meter. What is the distance between these two, section and the load? So this is your 4 minus x. So this is the force and the perpendicular distance about this one is your 4 minus x. So this is the moment here. This is the moment. So these are the moments. This moment is due to the external loading, and this moment is due to the unit vertical force, and this moment is due to the unit horizontal force. Then the moment of inertia is given for DC member I, and for CE member 2I, and for EB 2I, and for BA 3I. This is given. So this is for BC total 2I. For CD given I, and for AB member given 3I. AB member 3I. And for EB and C member 2I, and for CD member I. Then you find out what is the vertical deflection at D and what is the horizontal deflection at D. So for vertical deflection, you have to take the moment capital M and small m1, and for the horizontal deflection, you have to take the moment capital M and small m2. So this is the formula for vertical deflection at D. Vertical deflection at D is equal to 0 to L integration M small m1 by EI into dx. So you know for all the members and the origin and the integration limit and the moment. So just have to put this moment and the integration limit in this expression. So delta Vd is equal to so for DC, capital M 0 and small m1 0. So this is 0. And for C, capital M 0 and small m1 is your minus x. This is also 0. And for EB, the integration limit is your 4 to 6. And here this is the capital M minus 80 x minus 4 and small m1 is your minus x. This is 80 x minus 4 into x minus cancel. So by 2ei, what is the moment of inertia you are given? 2ei into dx. And for BA, so here this is the moment capital M minus 160 and small m1 is your minus 6 and the integration limit is 0 to 5. So here you take the integration 0 to 5, 160 into 6 by, and the moment of inertia you are given 3i into dx. Then you take the integration of this expression. Take the integration of this expression. Delta Vd is equal to this expression 40 by ei. That is the integration from 4 to 6 x square minus 4x into dx plus 320 by ei integration from 0 to 5 dx. Then after integration, the expression becomes, this is the expression 40 by ei x cube by 3 minus 4x square by 2 4 to 6 the limit plus 320 by x and 0 to 5 limit. So after putting the limit, so you get the vertical deflection at d is equal to delta Vd is equal to 2026.8 by EI. But EI value is given in the question. This is your 2 into 10 to the power 4. So after putting this value, so you get the delta Vd is equal to 101.34 mm. So this is the vertical deflection at free and d is equal to 101.34 mm. Similarly, find out what is the horizontal deflection at d, and for a horizontal deflection at d, so you have to take the delta hd is equal to 0 to L, capital M, small m2 by EI into dx. These two you have to take capital M and small m2 because this is the moment due to the unit horizontal force. So you have to take this moment here. Here also you know this value because for DC member, capital M0 and small m2 x, so this is your 0, and for C also 0, 4, this is 0, 0, 0. Then for EB, so capital M is your minus 80 into x minus 4, and m2 is your 4, and the moment of inertia 2i, and the integration limit is 4 to 6. This is 4 to 6 minus 80 x minus 4 into 4 by 2ei into dx. Plus for BA, integration limit is 0 to 5, and capital M is your minus 160, and small m2 is 4 minus x, and the moment of inertia is your 3i. So put here minus 160, 4 minus x by 3i into dx. So this is after taking the integration of this expression, then you will get this is delta hd is equal to 1 by EI minus 160 into x square by 2 minus 640x, the limit 4 to 6 plus 1 by 3i minus 640x plus 160 into x square by 2, 0 to 5. Then after putting this value, so you will get that horizontal deflection at d is equal to minus 720 by EI. But EI value is so you have to put here the EI delta hd is equal to minus 720 by 2 into 10 to the power 4. Then you will get minus 0.036 meter is equal to minus 36 mm. So the horizontal deflection at D is equal to minus 36 mm. Now you are clear that how to find out the vertical deflection and the horizontal deflection of a frame by unit load method. Then coming to second example, determine the vertical and horizontal deflection at the free end of the band shown in figure by unit load method. Assume uniform flexural rigidity EI throughout. So this is AB vertical member and C the horizontal member. In horizontal member C, so one concentric load is present at the point D. Then another horizontal concentrated load is given at the point B in the vertical member. And these are the length is given. This is the length for AB is 2 meter, BC is 2 meter, CD is 1.5 meter and D is 1.5 meter. So here you have to find out what is the vertical and horizontal deflection at T. So you have to apply unit vertical force here, and you have to apply 1 unit horizontal force at T, because you have to find out what is the vertical deflection at T and what is the horizontal deflection at T. So first you have to find out what is the moment due to the external force, that is M. Then find out the moment due to the unit vertical force, this is M1. Then find out the moment due to the unit horizontal force, that is your M2. So first you find out the moment capital M, small m1 and small m2 due to the external force and due to the unit vertical force and due to the unit horizontal force at E. So first you find out the bending moment due to the external loads. This is the figure. So here you take what is the moment between D and D, and what is the moment between C and D, and what is the moment between CB, and what is the moment between BA. So first you find out what is the moment here, because here there is what is the moment here between D and D, the moment is your 0, and between C and D, what is the moment here? So 20 into x minus 20 into x clockwise. Then what is the moment between C and B? So minus 20 into 1.5. And what is the moment between A and B? So here the moment is your due to this force minus 10 into x and due to this force minus 20 into 1.5. So put these moments in a tabular form. This is so it is 0 and DC member minus 20 into x and for CB member minus 20 into 1.5 minus 20 into 1.5. So this is your minus 30 and for AB member minus 30 and minus 10x. This is due to this one at here you have to find out. So due to this force minus 10x and due to this one 20 into 1.5 minus 20 into 1.5. So here the moment is your minus 10x minus 20 into 1.5. That is your minus 10x minus 30. Minus 10x minus 30. So this is your moment due to the external force. Similarly, find out. So in this figure, you apply the unit force are the P and E, and due to this unit force, find out what is the bending moment between D and E, and between C and D, and between C and B, and between A and B. So here you have to find out what is the moment due to the unit force at E. What is the moment here? 1 into x clockwise negative minus 1 into x. And what is the moment here? Minus 1 into this length is your 1.5 and this length is your x. So what is the moment here? What is the moment here? Minus x into 1.5 plus x. Minus 1.5 plus x. Here the moment is 1 into 1.5 plus x negative clockwise. Then what is the moment between C and P due to this force? Due to the unit force at E. So what is the moment here? This is your 1 into 3 and this is clockwise negative 1 into 3. This is minus 3. Then what is the moment here due to the what is the moment here due to the unit vertical force at E? So this is the 1 and what is the perpendicular distance when you are taking the moment about this? So 1 into the perpendicular distance is 3 meters. So minus 1 into 3. The moment here is equal to minus 1 into 3. This is minus 3. Then next you apply unit horizontal force at E, and due to this unit horizontal force, find out the moment between D and E, between C and D, and between B and C, and between A and B. So find out what is the moment here. This is the unit horizontal force, and due to this force, so what is the moment? Because this force you are passing through this axis, so the moment here is equal to 0. Similarly, here also between C and D, the moment due to this horizontal force is also 0 because this is your force and there is the perpendicular distance is equal to 0 about this point. So here the moment is equal to 0. Then between C and B, what is the moment due to the unit horizontal force at E? So what is the moment between C and B? 1 into x minus 1 into x minus 1 into x. This one minus x. Then what is the moment between A and B due to the unit horizontal force at E? So what is the moment here? So this is also, this is the force and this is the perpendicular distance. So here this distance is your 2 meter given and this is the x. So 2 plus x minus x plus 2. 1 into x plus 2 and the rotation is your clockwise direction. So you have to take negative minus x plus 2. These are the moments due to the external force and due to the unit vertical loading at E and due to unit horizontal loading at E. Flexural rigidity is your given constant. So you take EI for the entire structure. So that is your constant EI. Then you find out what is the vertical deflection at E by taking the moment capital M and small m1. And you find out what is the horizontal deflection at E by taking the moment capital M and small m2. What is the, then you find out what is the vertical deflection at E. Delta EB is equal to EI delta EB is equal to integration capital M small m1 dx. Then find out, then you put the value of M, capital M and small m1, and you know this is the integration limit for ED 0 to 1.5, and for DC the integration limit is 0 to 1.5, and for CB the integration limit is 0 to 2, and for BA the integration limit is 0 to 2. but the origin for ED is your E, and for DC D, and for CB the origin is C, and for BA the origin is your B. EDCB. This is the origin, because here you are taking the section from the point D. So here you have to take the integration limit from 0 to 1.5. 0 to 1.5. This is your 0 to 1.5. Then for CB 0 to 2 and for BA 0 to 2. Then this is given. So find out what is the vertical deflection at E. So this is after putting this integration limit and the value capital M and small m1. After integration and after putting the value, so finally you get delta EB is equal to 476.25 EI. So the vertical deflection at E is equal to 476.25 by EI. Similarly, find out what is the horizontal deflection at E, delta EH. So EI delta EH is equal to integration capital M small m2 into dx. Then here you take this one capital M and small m2, and this is the integration limit you take. Then you find out horizontal deflection at T, the EI delta EH is equal to integration m2 dx. So this is the M capital M and small m2 you have to put here. Then you have to take the integration limit. Then after simplification, so the horizontal deflection at E is equal to 306.67 EI. So this is the horizontal deflection at the free end of a bend. Now all are clear. So how to find out the deflection of a frame by unit load method.